We are here to talk about our periodic trends, parts 1 and 2. Today in class, you got some background information on the periodic table and started to get a little bit more familiar with it. The purpose of this video is we're going to go through two trends. Part 1 is on metals and nonmetals, so your notes should already be set up and we're ready to go. Starting with the basics. Columns on the periodic table are known as groups. Some groups are also families, which you can see currently in rainbow here. Groups share similar characteristics like reactivity. Rows are known as periods. Periods have the same number of energy levels for their electrons. So example, that first row, first period, has 1 energy level. The second one has 2 energy levels. The fifth one has 5 energy levels. The staircase, which we're going to draw in just a second on our periodic table, divides metals to the left and nonmetals to the right. And you'll notice when you draw your staircase, about 80% of all elements are metals. So go ahead and draw your staircase. And look how far over to the right it is. All of the left are metals, all of the right are nonmetals, except hydrogen. If you need to, at this point, go ahead and add a key to your periodic table. A lot of us already have oxygen, but if you need to add a key with what's happening on your periodic table, go ahead and do so. I picked bismuth just because it's my favorite element, but you can pick whatever you want. Now we're going to go through the families of the periodic table. You can choose to color code these if you wish. Just make sure that you make a key for what families are which color, either on the periodic table itself or in your notebook. And there's an example that I'll link as well that you can just see if that's something you're interested in. It is optional. What you do need to write are just some brief notes and of course the names of the families as well. So my first group on the periodic table are my alkali metals. We saw this in a video of how reactive these are and that the reactivity increases as we go down the periodic table. So sodium is more reactive than lithium, rubidium is more reactive than sodium, etc. Note, hydrogen is not in this group. It's because hydrogen is not a metal. Alkali metals like to form strong bonds with the halogens. We'll see that when we get to the halogens as well. That's going to be group 7. Our alkaline earth metals are group 2. These are also very reactive. Both my alkali and my alkaline earth metals are not found in their pure form in nature because they bond so well with some of my other elements on the periodic table, and it makes them more stable to bond. So these really unstable ones aren't found just by themselves. Transition metals are kind of that lower chunk in the middle, and these are the traditional metals you're more familiar with, things like gold, silver, copper, iron, maybe iridium, platinum, mercury, those kind of things. And these are found on their own in nature. We can mine some of these by themselves. They also do form bonds with other elements, but it's really hard to predict how these form bonds. So when we get into more making molecules later on, we don't talk too much about the transition metals. This is just a reminder from earlier today that those elements that appear at the bottom of the periodic table are actually inserted within that middle part of our transition metals. We just chop it out and put it down there so it fits nicer on a piece of paper, but I just wanted to remind you where those kind of actually appear in our periodic table. We have a dense clump here after our transition metals of a bunch of things. So our post-transition metals, except aluminum, have slightly different properties than the transition metals. Those elements that touch our staircase are called semimetals, and they are that way because they have properties of both metals and nonmetals. And one of these that's really popular is silicon, which you can see up there. And silicon is one that's used often in making our electronic devices, and it's because it's a semimetal. It doesn't quite conduct heat as well as these transition metals, and it has other properties that can be beneficial. The nonmetals are here in blue, and those are some that are really important to what make us up: carbon, nitrogen, oxygen, phosphorus. Those are really important. And they tend to either be gases, like nitrogen and oxygen, or some brittle solids, something like the graphite in your pencil that's made of carbon. Towards the end of our periodic table, we have our halogen group. That is our second most reactive group after our alkali metals, and they like to bond with our alkali metals as well. So these are not found on their own in nature. They like to form strong bonds with alkali and alkaline earth metals. And unlike the alkali metals, where as we go down the periodic table they get more reactive, my halogens are the opposite. So if you look at the blue group, fluorine at the top is actually the most reactive of my halogen group. And finally, group 8 is noble gases. So my noble gases went undiscovered for a long time because they're completely what's called inert, super unreactive. They don't form bonds with other elements. So they were hard to find because they weren't popping up anywhere because they were so content being on their own as gases. At the very bottom, we have our rare earth metals. We don't talk too much about these. These took a long time for scientists to narrow down and to find because they're really incredibly hard to separate from each other in nature. And their atoms are also super, super big. You can tell by their atomic numbers. So because of this huge number of protons and neutrons, they also tend to be radioactive. So we've already talked about quite a few of them. You'll recognize their names from when we learned about radiation, but they form weird types of bonds, so we won't talk about them too much in this unit. The three exception elements are notably aluminum and hydrogen. So hydrogen is grouped with the alkali metals because it forms bonds like them, and it has similar trends that we'll see in a bit, but it's a nonmetal. It's the only nonmetal to the left of our staircase. Aluminum is actually a true metal, but it's a little bit more predictable than its peers. So it's, even though it's on that line of the semimetals, because of how predictable it is and how it bonds, it is a true metal. And then helium is in the noble gases family, and it is a noble gas, but it has a different number of what are called valence electrons, which we're going to learn about in a minute. So pause here, do a quick self-check, see if you can answer these questions. Each element in a period has the same number of energy levels, and each element in the same group has similar characteristics and reactivity, and one other huge trend we're about to learn about. Valence electrons. So valence electrons are the electrons in the outermost energy level of an atom, and these are furthest away from the nucleus, right? They're farthest out, outermost energy level. And the reason we care so much about these is because these are the electrons that are either transferred or shared when atoms bond. So we're in our molecules unit now, and we're actually going to kind of start to ignore our nucleus and all of the other electrons that aren't in this outermost energy level, because those are the ones that are far enough away from the nucleus that we can actually exchange and share them to form bonds. So these are going to be really important. So go ahead and look at your periodic table. We call these tall columns. You can kind of see these groups on the end here. Those are what we call the representative elements, and those are the ones we focus on when we talk about bonding because they are more predictable. And we wanted to just make sure you know that they are called representative elements because I'll start using that term. All the representative elements in the same column have the same number of electrons in their outermost energy level. So remember, we just learned that that's called valence electrons. So every element in group 6 on the periodic table is going to have 6 outermost electrons or 6 valence electrons. Go ahead and label your periodic table with that. That way, if I ask you, well, how many valence electrons does this element have? You can find it on your periodic table, look at the top of the column, and boom, you know the answer. Here is our alkali metal family. And I just wanted to show you what it looked like, right? So if we draw out all of these elements, you can see that in hydrogen, there is 1 outermost electron. In lithium, there's 1 outermost electron. Sodium, 1 outermost electron, etc., etc. So these are all grouped together in the first group as alkali metals because they have 1 valence electron. That's also why they're so reactive. So pause here, find these couple of elements, and see if you can tell me how many valence electrons there are. There's your answers. Now, drawing out the nucleus and all of those different levels of electrons can get kind of tedious if the only thing we care about is valence electrons. So we're going to learn about something called Lewis dot diagrams, where we're going to be able to just draw out those valence electrons. So you'll see if I look at, let's say, group 5. I have 5 valence electrons in both of these, etc. So we'll get some more practice with that. I just wanted to introduce it as an idea for now so we don't have to draw out all those levels. Final check-in here. See if you can answer it. We'll go over the answers on the next slide. So in this element, I see 2 valence electrons. That means it's an alkaline earth metal. And this one I see 2, 4, 6. 6 means it's a nonmetal. So these are just for you to check your notes. So you can pause, Look through this, make sure you have all the information that you need. Same thing with our periodic table. You could have colored your families if you wanted, but you absolutely need to have the staircase drawn and your valence electron trend drawn at the top as well. That's it for this video. We're going to get some practice with this before we move on to our next two trends.